JA3 talk was yesterday at 1 p.m., so this is not networky stuff. It's all host obfuscation things. So if you want a JA3, you're welcome to leave now if you don't want to look at more coffee memes and stuff like that.
Do you know the one where did you hear that the stirred and stirred it turns into a cockroach?
No, that sounds horrible. I mean, I want to see it, but it sounds horrible.
All right. Google for you should go find that and put it up there.
Hey guys, hi, good morning everyone. Thank you for coming to day 3 and thank you. I just lost count. Can everybody do me a favor, please? Look around and see if there's any trash on the floor. When you guys go to leave, please take it with you and deposit it. Okay? We're trying to make this nice and easy for the hotel. Okay? Because pardon me.
Probably. That sounds like its origins, yes. You never know what's in those pods. Who cares where that comes from? Yeah, we can go and start. All right. Welcome, everyone. This is the Sunday afternoon track. Today I'll be talking about invoke DOSfuscation, techniques for fin-style DOS-level command obfuscation. As I said a few minutes earlier, this is not the JA3 talk. I had some severe travel woes, and I was fortunate enough to be able to swap with the JA3 talk, so they were actually yesterday at 1 p.m. So this is not networky stuff. This is host obfuscation and coffee meme stuff. My name is Daniel Bohannon. I am a senior applied security researcher with FireEye. Prior to that, I spent several years doing incident response with Mandiant Consulting. There's my Twitter handle and blog. I have a bit of a crush/obsession with obfuscation and evasion detection work. So these are some of the projects I've done over the past couple years. Invoke Obfuscation and Cradlecrafter in regards to PowerShell obfuscation. And then Lee Holmes and I worked on a detection project called Revoke Obfuscation. And then today we'll be talking about Invoke DOSfuscation, in particular looking at all the obfuscation and evasion woes that command.exe happily supports for us. Brief disclaimer, nothing I'm talking about is outing any particular client or customer of FireEye or Mandiant or anything like that. So a quick outline for today. We'll be looking at a high-level overview of kind of obfuscation, past, present, future, and then diving straight into 3 case studies that propelled me into this research. And then we'll be looking at ways that you can obfuscate, all within the realm of command.exe, obfuscate the resolution of binary names, and then dive into character insertion obfuscation, and looking at all the characters that can make their way into command line arguments that persist in some really interesting places that affect the way that we as defenders write detections, as well as then putting all those pieces together and looking at entire payload encoding and obfuscation techniques. And then we'll do a quick demo and then talk at the end about detecting DOSfuscation. So all these slides are available online. Also, if you don't like the sound of my voice, you can read all of this. There's a 36-page white paper that is very colorful and animations, or not animations, I guess graphics and stuff like that. But I would say for the defenders in the house, there's the last several pages in that white paper go into a lot deeper dive into detecting it, even with like code snippets and stuff like that. And so as we get to the tool demo, I'll talk more about the test harness that I released with the tool, which is the exact code that I developed for myself to produce all the detections that we use for this kind of obfuscation. So, state of obfuscation, where are we at today? The red teamers in the house probably enjoy obfuscating because it's cheap, easy, and fun, and it's still pretty darn effective at evading rigid detections. And it also increases the work for us as defenders. Even if we're good at detecting something that's obfuscated, it still takes a few extra steps to remove that obfuscation and see what's happening, especially in languages that aren't like PowerShell, where you have a lot of excellent logging that will unwrap a lot of those things for you. There is no such logging for command.exe and for most other scripting languages, so it definitely increases the time that we have to work to unwrap what's actually happening. And there's obfuscation frameworks that exist for almost any language you can think of or would want to use, and even though I may be biased, I don't really see this slowing down anytime soon. So kind of the response from the blue team is, over the years, we've been getting better visibility into what's executing on the system. Things like AMSI and ETW, some are old, some are new. And also looking at different ways of using like data science approaches to detect what does not match the description of normal. But there's always room for improvement because attackers, although they might be impressed for a slight second about this, they're not going to stay stale. They're going to respond in one of several ways. First of all is they can just choose softer targets. No matter how amazing new detections are and new visibility improvements are, it still takes years for people to adopt these things. And so an attacker can just choose a softer target. They can just go straight for disabling these advancements in defenders' visibility, or they can just use languages that don't provide additional inspection visibility like what we see with PowerShell today. And they can just always roll their own custom binaries because application whitelisting is still pretty darn uncommon, even though it's pretty awesome. So this talk isn't about any of the PowerShell obfuscation. We're going to be completely sticking with command.exe. And primarily, as a defender, when people look at detections, it's typically, you're going to see detections written on command line arguments. That's kind of the easiest to get to or the most common. Some people may pull in things like this binary making this network connection or making these many DNS lookups in a given time frame. But you could also look at things like parent-child process relationships, as well as this binary being the source of action, like this binary modifying this registry key or writing this file or something like that. The problem is that command.exe is super common. It's used for everything. It's running all the time. So how do you filter through all the common usage of it and find what is malicious, especially if attackers are trying to hide it with obfuscation? So why did I start this research? What propelled me into this area? A year ago, back in June, this is my manager, Nick Carr, and so we co-authored this blog post where in the first half of last year, we saw 3 really, really interesting and impressive obfuscation techniques by 3 different groups, 2 financial groups, FIN8 and FIN7, and then APT32 operating out of Vietnam. And so there's a high-level overview of what was in this blog and the samples that we saw them use. So in February, we saw FIN8. This is an extracted, this was already obfuscated in a macro. This is the extracted portion. But what we can see is that the attackers set different process level environment variables. So in the bottom, they set this PowerShell command, which is referencing even more environment variables that were set from the parent process. The second variable is PowerShell dash. And then the top is actually what runs. So we see WinWord spawning command.exe, and then it's echoing environment variable 1, which is at the very bottom, and it's echoing that, piping it into PowerShell dash, which means this PowerShell command will be run by PowerShell as standard input, which is what the dash signifies there. Now this is really cool because if you're only looking at command line arguments, all you're going to see are the names of those environment variables for that first process execution, and then you'll see when PowerShell runs, but you'll just see PowerShell dash unless you go into PowerShell logging to see what's happening there. But a really cool way that they're using command line evasion. APT32, We've seen them use, just like a lot of other people, carets, which is the command.exe's escape character. But they were the first ones to really, the way I say is tastefully use double quotes as obfuscation characters. In this case, they were using Casey Smith's squibbly-do regserve32 binary app whitelisting bypass, and they were specifically targeting just the HTTP portion of the /i argument, realizing that a lot of defenders were writing detections looking for HTTP, but not necessarily taking into account carets or double quotes breaking up that string. And the last one, this example is the example that got me just completely fascinated with this area of obfuscation. This is from Fin7, and the last one was APT32. APT32 and Fin7 to me are my favorite groups in terms of like really driving very specific and tasteful obfuscation. And so I really do love following the artistic nature of their work, I guess you could say. And so this actually came from a malicious link file that they dropped from a Word doc. And as you can see here, they did some JavaScript level encoding. They're echoing out some JavaScript to a text file called md5.txt. And they were doing some nice concatenation. And instead of eval, they have a nice ASCII conversion for the E and then concatenating it with val. But what's in the red boxes is what really baffled me for a while, because if you'll notice, it's WScript and it's argument JScript, but you see those @signs in there. And this really stumped me because I couldn't reproduce those exact commands on the command line. I kept getting errors. So let's break this down and see what they're doing. First, they're just setting their WScript command into a process level environment called X, which is that set X equals, and then they echo out the JavaScript to a text file. Then at the end, they run echo the contents of X, and they're piping that into command. So they're running an additional command.exe process, which is running the contents passed in a standard input. So there's our variable X, which they're setting it and then executing it. But they're inserting these garbage delimiters, these @signs, into WScript and JScript. And then what they're actually doing is these actually aren't valid obfuscation characters. WScript will fail if you have those @signs in there. But what they're doing is in that environment variable X, when they're echoing it, they actually make space after the variable name, and then they put in this syntax right here, which is actually a native command.exe string replacement, which says find every example of the string just the single character @sign, and replace it with what's on the right side of the equals, which in this case is nothing. So it's saying in memory, remove the @signs, and then continue as normal. Now this freaking blew my mind. Like, it was such finesse. So this was really cool, really impressive, and evaded a lot of static detections, and it really impressed us. And we definitely went back and started to rethink some of the ways that we were tracking this kind of activity. And again, I had no idea that command.exe was capable of doing string replacements like this. So basically, we found this sample on Wednesday. We wrote this blog post on a Thursday, published it on a Friday. I went home, couldn't stop thinking about it. That Saturday, I wrote up this POC called out FINcoded command, so like encoded but for fin groups. And then I released it on Sunday morning. And I remember as soon as I released it, I stepped back and thought, I wonder if there's more here. This is just one component of command.exe I never knew about. What else is out there that maybe some admins use all the time, but like I've never seen used in the wild, and would be kind of building blocks to make more interesting obfuscation techniques? So implications of this research, particularly for us as defenders, these obfuscation techniques will affect dynamic detection. So if you're reading in real-time process execution arguments, then it's definitely something where a lot of these will still affect that. They're not all removed, especially a lot of people will say, okay, well, in that WScript example, I don't care because WScript will finally run. And hopefully by the end of this talk, we'll see there are certain obfuscation techniques that will cascade down to whatever child processes you have. And also there is value in taking the obfuscation into account in certain detections, because you don't want to give up, even if you can detect something dynamically, you don't want to give up your static detections. So let's say you can detect something running out of a registry run key when it runs. That's great, but what if an attacker installs a service to run 6 months from now and you miss it every single time you scan that services registry key because you're not looking for the obfuscation? Another really awesome thing that we like to do is just looking at all the open source opportunities we have to gather examples of payloads, and if we're looking for obfuscation specifically, then we can find a lot of interesting payloads without ever having to even execute it. So at a high level, by the end of this talk, we'll be able to take any arbitrary command, like this simple echo command, and add layer upon layer of obfuscation and get something that looks more like this, and we'll see exactly how it all still works. So hang on tight. I am very jet lagged and I'm very caffeinated, so this is going to be a fun ride. I will be around afterwards for questions, and my Twitter DMs are open. But let's hang on tight and let's piece all these things together and build something that hopefully will challenge some assumptions from both red and blue, and we'll learn how to start going about detecting this kind of obfuscation. So let's talk about obfuscating binary names. Now there's a couple different things that I'm not talking about here. I'm not talking about detecting if an attacker renames command.exe to foo.exe and then runs it. I'm also not talking about command-like substitutes, like some of the lol bins that Advar Mo, who was here, has kind of put together into the lol bins and scripts project. So we're not looking at like for files or PCA Lua or stuff like that. We're still talking about the exact command.exe binary, but what are ways that in the command line arguments we can reference a binary name like command or PowerShell or something like that, but that the string never shows up in those command line arguments for that first execution as the string command or PowerShell. So it's syntactical obfuscation of the legitimate binary name. So what do I mean by that? Well, one thing we can do is use environment variable encoding. So there's a lot of default environment variables in Windows, as with any operating system, and what we can do is extract substrings of that. So program data is going to produce C program data, assuming that C drive is what you're using, which is maybe not a great assumption to make for all red teamers. But if we then echo out substrings, then we can actually have it produce the string CMD. And we can do that for CMD, for PowerShell, or whatever you want. One thing to keep in mind is that for known environment variables, when you paste this into a command prompt, you actually won't see this obfuscation in the event logs because it resolves immediately in that session. And so we'll look at ways that we can actually keep environment variables from not resolving, and so that you'll still get this obfuscation effect when you execute the code. But what I was looking for is, okay, if those environment variables don't really bias any obfuscation on the command line because they resolve, then how can I find a way to do something that doesn't resolve in the arguments, but still in memory will produce the string command or PowerShell? And so what I ended up settling on was looking through all of the internal commands for command.exe that I could find, because I didn't want something that would be another executable that would produce another process execution. So set, assoc, and ftype were the three that I used primarily in this project. Set will show you all of the environment variables, and then assoc and ftype are related. Assoc will show you the association between a file extension and the associated file type. And then ftype will basically show you that the association of the file type to the actual binary that will run if you double click on that file type with that file extension. So let's just use set. It's a little bit of an easier example. So what I did is just said, okay, let me run set and just find string and see if I type set, the standard output that comes back, can I find the strings PowerShell or command? And so let's just use PowerShell as an example. So if I do set find string PowerShell, I'll see it in two places. One is the path variable, and the other is the PS module path variable. Now, as an attacker, I probably wouldn't want to use the path variable since that's likely going to change on different systems. But the PS module path is probably more likely to stay exactly the same on most systems, especially if they're not heavy PowerShell users. But what we can do is there's a lot of different substrings we can use for find string to produce that same PS module path. So this is a code snippet from the invoke DOSfuscation code, which will just every time you run it randomly choose one of these case-sensitive substrings of PS module, and will produce just the PS module path result. So what we can do then is once we have that result, we can introduce delimiters for the plain text string. So if we choose the delimiters lowercase s and backslash, then we can see that will properly delineate the two instances of the string PowerShell in that whole blob of text. But it'll also produce 13 different little substrings of this entire piece. So we're now interested in, if we use these two delimiters, we're interested in the 4th and the 11th pieces. So now the way that I do this on the command line is the only way I found to execute an internal command within a session and grab the contents and store it into an environment variable in that session is to use the for loop. So it's very convoluted, but here's how it works. It's basically in the far right, we see we're running our set find string PSM as a subcommand. And in the for loop, we're introducing the delimiters because for loop supports that for us. And then we're saying, I want token number 4, and it's storing that in the environment variable A. And then we just say do A. So as we can see, we run it down here, and it in memory produces the string PowerShell and then runs PowerShell. So now in this example, when this runs, then PowerShell, we're not going to see that in the first execution, but since it's a binary, it's going to run in the second execution. But this concept can be extended to produce any internal commands that may not actually produce a child process. And an example of where this may be applicable. I actually don't drink alcohol. Yeah, I'm sure you do. Oh, it's disgusting. Thank you, sir. This is good for jet lag, right? Oh, it's bad. Yes, exactly. I don't remember it stinging this much. Maybe that's why they came up with those V8 splash things. A little more tolerable. You guys actually don't know when this is finished. I could stop and be like, I just crushed this. But I'm honest, so I'm going to keep going. Let's look at the next outline section. I wish this was a section on caret obfuscation, which would be like perfect for the V8 stuff. Oh wait, it is! So the caret escape character.
You want water?
I'm good. I'm good. Whew. All right. The caret escape character, the most famous obfuscating vegetable. So this is the most common escape character that we see, or the most common obfuscation character that we see for command.exe. A lot of people don't realize, though, that the escape character typically doesn't apply to the child processes. You have to double escape or quadruple escape, but it really depends on if the child process can handle escape characters. Like WScript can't process escape characters like command, but that's where the double quotes come in, and as long as you have evenly paired double quotes, or evenly balanced across the command, then it'll actually go down into the child processes. And we'll see that in some examples in just a few minutes. Encapsulating parentheses, this is something that I first saw used by Newscaster. I don't think they were using it for obfuscation purposes, but I didn't know it was possible. But you can start to wrap commands and certain subcommands in any number of evenly paired parentheses. Leading and trailing special characters, the comma and the semicolon. You can actually, someone hit me up on Twitter a little while ago and was showing that you can also start commands like with the equal sign and a lot of other things like that, that command.exe will kind of strip off leading characters. But this actually came up from basically writing just a quick fuzzer to take a known command that executes and produces a known result, like just maybe executes a bat file and then prints success. And let's put that into a little test harness and say, now go through and in each area of white space, insert any random character, and then let me know when any of those commands still work. And so that actually helped me find the comma and the semicolon to say, hey, you can actually use these in the same places you can use white space delimiters for command.exe. And we'll see how that can make some really ugly commands when you put all these together. Standard input argument hiding, we looked at that in one of the previous examples. Using non-existent environment variables, this was a technique that was blogged about many years ago, but it's only applicable to batch files because if an environment variable doesn't exist, it'll just resolve to nothing. On the command line, however, it just won't resolve to anything, and then you're stuck with %a%, and it messes up your command. Custom environment variables within a single session setting and substringing. In this case, they're breaking up the string PowerShell, setting that into the variable P, and then using existent environment variables, which we looked at earlier, for doing substringing. So the FINcoded command POC, I included a few, and this was the initial POC that I released after coming across Fin7 using this stuff. And so I added as input these obfuscated command and PowerShell things using environment variables. And someone quickly replied back with this huge command and showed that you can apply this to full payloads. And actually, as we started to look closer, attackers have been doing this for a while. Fun fact, a lot of people just copied and pasted this command and then got mad at me. And I was like, I didn't write it, and why are you copying and pasting stuff off the internet and running it? So yeah, that was kind of fun. So again, as a defender, as I start to do this kind of offensive research, I want to see, has an attacker been using this that we've missed? And so as I started to kind of go through and retro hunt through VirusTotal, through our own execution reports and our file repositories, I started to see that just from an environment variable substring perspective, yes, there's been a lot of malware that's been using this for many years. This one was from 2012, but I'm sure it's been going on like well over a decade before that, just because it's just something I hadn't seen before, but this is a batch file kind of interspersed with substring obfuscation. Another one is the JS batch obfuscator. So instead of using known environment variables, they'll set like a dictionary key in a custom random environment variable, and then the rest of the payload is just substrings of that variable. This is actually a really cool project. It's been out for about 2 years on GitHub. It's like the tiniest obfuscator I've ever seen. It's just like a really cool like side-by-side window pane JavaScript. So definitely worth checking out. Like as you type the command, it's like re-obfuscating it. It's pretty fun. And then this one, I won't go into too much detail about what this fish was where we found this, but there's a lot more in the white paper. But basically there is a tool called batch encryption, and it's a combination of obfuscation and encryption, and they actually do a combination of first setting their custom dictionary using known environment variables, and then using that, they're storing it in an environment variable with the name single quote, and then the rest of the command is substrings of that single quote. Pretty nasty stuff. All right, so we've looked at how we can obfuscate binary names through doing like the for loop and using internal commands to resolve command or PowerShell. We just looked at the ways we can introduce obfuscation like insertion characters, and now we're going to put all those pieces together to encode entire commands. So I chose this as the first command to look at just because if there's any defenders in the house, the first portion of this command should probably make the hair stand up on the back of your neck, because comspec bc start b min pretty much never means a good thing if you see this like in a 7045 service creation or anywhere else in event logs or registry keys or anything like that. And I want to start with this because a lot of detections are written looking for %comspec%, but anytime I'm looking at detecting an attack technique, I want to break down all the components of the command to see what do each of these mean, which of these are necessary, and how can I build more resilient detections based on what's required and what might just be copied and pasted by attackers, because that's what the POC included, so obviously it must have to include it, and no one really questions those assumptions. So comspec is the environment variable that resolves to the full path to command.exe, and then there's a brief description on some of the other flags that are there. But for comspec, there actually are ways that we can screw around with this and maybe break some detections that look for %comspec%. One is using environment variable substrings. So comspec resolves to 27 characters. And so we can do something like this and use environment substrings to basically say start from the 0th index and go forward forever, or 0 to 27, or we can also use negative indexes as well. In addition, we don't have to stick to the length of the variable. We can use any longer length and it will still work just fine. So you can use leet as your substring length there, and it will still resolve to the exact same command. We can also go the substitution route, which is kind of more along the lines of what Fin7 was doing. So we can say, okay, replace every backslash to /. Or you can use things that will never even show up and replace it with something else, but it doesn't change the value. But we're still just trying to say, can I make %comspec% be something else, right? And so again, detections that are looking for %comspec% will completely miss these iterations here. So we'll just go with those two examples and keep going. We can randomize the case of the variable. We can also introduce a ton of white space. On the bottom example, this actually does change the behavior. But again, I don't care in this example because I'm okay if nothing changes. I just want to resolve what the syntax is there. We can add explicit signing. And we'll just go with a second example and keep going. Now, what's really important here is that context matters. You can copy and paste this into a command prompt and it will work. You cannot, however, copy and paste this into like a service or run key because it won't work, because basically it has to understand the concept of I'm already in command.exe to know how to handle this substring syntax. Now, that's true for the first command. So let's say that later in the command we're using this syntax, we have to at least start the command with a non-obfuscated version of command.exe before it'll know for everything else this is how we handle substring syntax. But for the rest of the command, we can randomize the case. An interesting thing is that between command.exe and the first argument, you don't actually have to specify a white space when you're storing that like in registry or executing it interactively. But the operating system will actually introduce an extra white space after that binary. So it's important not to just look at the command you're copying and pasting in, but to check the data source that's coming out. And this is true whether you're looking for this in process event logs or capturing this in real time using some other artifact. But sometimes it does require that you modify your detection, whether you're looking for the static thing that maybe this is stored in registry versus the execution result that comes from other data sources. Netstats arguments can be reordered. We can add white space to the remaining command. We can also add all of those commas and semicolons because those are white space delimiters. And so we can add that in all of those places. We can then add a layered caret escaping, and that will persist a couple layers down depending on which binaries will still handle carets. And now if we look at the process execution for this, going from the bottom to up, this actually has a couple processes, right? It has the find string for listening. Eventually we have netstat, but you'll see this intermediate command, the portion highlighted in yellow. We'll cover this very briefly at the very end in the detection section. But basically, if you see command.exe, 2 spaces /s space /d space /c, no space, double quote, then a space, and then something else. This is actually an artifact of the operating system, and you'll see this if you have things like if you're echoing content into another binary, a standard input, or if you're executing something as a substring or as like a subcommand, then this will actually be a natural artifact of the operating system. So there are actually some fascinating detections that, given this little bit of context, you can kind of understand this one little command that ran came from one of these specific contexts, and now it's a more interesting command. And so as we look through the detection section, I actually do use this in a lot of detections, specifically for DOSfuscation, because it gives me an extra bit of context in terms of where the command came from. But an interesting thing is that in our final command netstat, none of the obfuscation made it, except for randomizing the case in white space. Like, what about all the carets and the commas and semicolons? Well, they didn't make it because netstat can't support those if we put those all the way down into the command. But there is a character that can make it into, as far as I've seen, every binary I've worked with, this character will still work and will still obfuscate, and that is the double quote. So as long as we have an even number of double quotes, we can put that in the original command, and it will persist all the way up or down, depending on how you're looking at it, into all the child processes. So with invoke DOSfuscation, you can basically hand it any input command.exe command, and it will support and randomize all of these obfuscation components, whether you want this additional obfuscation or not, and it'll handle all the layers of escaping for all this stuff. And this is my world's tiniest violin slide, because this is where I kind of feel sorry for myself, because this really sucked to build, because with PowerShell obfuscation, at least I had access to things like the language tokenizer or the abstract syntax tree to be able to piece together what every piece of the command was, but there's no such thing for command.exe, and it made it really difficult, but it still works pretty much all the time. So, yeah. So as a defender, you may again say, okay, well, I don't care about this obfuscation because the child process will still run and I'll catch that. Well, one of my pushbacks on that would be there's a lot of reconnaissance commands, let's say, that an attacker could run that never produces a child process. So let's say that each of these commands in red was completely wrapped up in DOSfuscation, and you never saw, like, these actually won't produce a child process. Copy is not, it's an internal command, so you're never going to see copy.exe running, or like del for delete, or for reading the contents of the host files or something like that, or just doing directory file listings. So there's a lot of these kinds of things that I still want to know about, even if they never produce a child process and they're wrapped up in this kind of DOSfuscation. So when it was all said and done, with the DOSfuscation research, I was able to come up with 4 different obfuscation options, like for the entire payload. And the first one we're going to look at is concatenation. So again, if we start with our netstat command, one thing we can do is change the dash and the slash. So in pretty much any binary that's using arguments, you can start to swap around slashes and dashes for that. So let's go ahead and do that. And there's a lot of other examples, so like WScript's no logo, PowerShells, you can change that from dash to slash, and then redserve, you can do slashes to dashes, and then also in the URLs, you can also pop those backwards if you want. And even PowerShell becomes a bit more permissive, where you can do mismatching, forward, backward, backward, forward. So there's a lot of fun you can have with slashes and dashes in general when it comes to detections. But we'll move onward. So for the netstat command, let's just set that in a process level environment variable called com, and at the end, let's just echo com and then look at the contents. Now at the top one, if we just echo com, we actually just get the string %com. It doesn't give us the value. So the way we have to do that is we can use the bottom example, which is just create a child process, and the child process and any sub processes will correctly resolve the recently created session level environment variable. But if we don't want to create a child process, we can do it in the same process if we use the call internal command, which will expand that variable for us. So let's change that to call up there and then run it. And as we'll see, okay, this successfully runs our netstat command and gives us the proper output. So now let's break up the netstat command into 3 variables, com1 through 3, and then let's call the concatenation of com1, 2, and 3, and we'll see that that works. I'll go forward on this. Basically, this was some stuff with sysmon, where in some older versions, the escaping wasn't properly handled, and so using these percents showed up as 2%. There's a blog post if you want to read more about that, but if you're using sysmon EID1 for your detections, you definitely want to take a look at that and what it might mean for you. We can also reorder the substrings as long as we properly order them back into the final step, and then we can set all those final substrings back into a single variable. Let's call it final, and then we can execute whatever we want with final. So the final syntax, there's 5 different options in the tool that are supported. One, as long as we're not using certain special characters in the input command, then we can just use that call internal command and not have to worry about producing another child process. So this is the cleanest way. However, we can do a final process and say, let me do all the obfuscation and then do an and then either do command/c for a child process or echo the final result variable into a child command.exe process. And then 4 and 5 are the same, except it's for PowerShell. So if you want to input a PowerShell command, then DOSfuscation will introduce all of the command.exe DOSfuscation and wrap that and support the PowerShell level obfuscation characters as well. So it's kind of an obfuscation inception that I definitely shouldn't have done because it took way too many, it took way too long to do, but it was definitely an interesting challenge to kind of wrap 2 different languages together from a layered obfuscation perspective. And then invoke DOSfuscation will handle all the building block techniques that we talked about. So we can randomize the case, we can add white space or remove white space. We then introduce commas and semicolons wherever possible, as well as carets, as well as parentheses. And these are all handled by different like obfuscation level profiles in the tool. So when it runs, we'll see we get our proper netstat command. And again, if we wanted to break that up, we could introduce paired double quotes. But now an interesting challenge that came out pretty quickly was, what about if I want double quotes that aren't adjacent to one another? Like in the second example. This is actually a really difficult problem for me because we can't just make those double quotes different in the main command because we have double quotes surrounding the very end of the command in the beginning because command.exe is using that to say here's what all the arguments are. So this actually doesn't work. And the solution that I came up with is a 4-step solution that the tool will automatically handle if you have any of these double quotes. But basically what it comes down to is anywhere where I want single or where I want non-adjacent double quotes, I change that to paired double quotes because it'll show up that way in the argument. So I set it to be double. The next thing I do is I set another variable that stores quote, quote. And then I create white space at the end of the final variable, and I'm going to use that FIN7 style string substitution to say anywhere in our command where we have quote, quote, I want to replace it just with one quote. The problem is I can't put one quote here because then we have an unbalanced number of quotes in the command. So what I do is I reference the quotes variable and say, give me a substring of that sucker. So statically it's balanced, but in the memory it's unbalanced and it properly translates that to remove the 2 to 1, and that it actually almost works, except it doesn't. Because now the percents here for quotes are inside of the percents for final, and so that doesn't work. And so this was, I felt like I was so close, and then that got me down the path of, can you actually reference environment variables in command.exe and not use percent signs? And the answer is, as long as you're running Vista or later, you can use the Vista flag and do this. So now what you can do here is that you can use exclamation points instead of percents. And now those don't interfere with the percents inside of quotes, and so that works. So, and you can see when we run it here, then the double quotes that finally come out aren't adjacent. Now, if you took a picture of that last slide, don't tweet it out just yet, because it's actually a troll. But it does work, I promise. The Vista flag does work, but there's actually no such thing as the Vista flag. If you look at Commands Help menu, you see there is a v:"on" flag to enable delayed environment variable expansion. But turns out you can do any substring of v:"on, as long as it's not v:"off, and then v pretty much anything, and it'll still work. So I actually haven't tested this on older systems older than Vista, but yeah, there is no Vista flag, but you're welcome to put Vista on there. We'd love to see that. So in addition, the tool will also handle the random environment variable names. So instead of com1, 2, and 3, you can do special characters only if you want to, and that still works. Or you can do different amounts of white space followed by a single non-white space character, and these are all separate commands or separate environment variables that will still produce the same result. So, all right. What's the benefit of this? Why'd you do this, dude? Well, concatenation is something that we've already seen attackers dabbling in, specifically for like link file obfuscation, for breaking up the string PowerShell or stuff like that. Here's another one where they're introducing a lot of garbage characters as well, or garbage variables. But yeah, so attackers are doing this for small pieces, like for one piece of the command. But we really hadn't seen attackers doing full payload encoding like this until after this research was released. So that was one of the 4 techniques. That was concatenation. And the next thing that we'll look at are going to be things that before this research we didn't really see attackers doing. We've, for some reason, seen a lot of it since then. And so at the time, when I released this tool earlier a couple months ago, when I said we haven't seen it, we've been looking for it really freaking hard across internal and external sources, and also running it as endpoint detections for a lot of endpoints, and hadn't seen any indication of this being used. So that was kind of fun. So for loops are awesome. For loops really give you a lot of bang for the buck. And so for loop encoding or FORcoding was the next thing I looked at. So when you look at the command help menu, V on says it expands the variables to input time, which is quite a different thing when inside of a for loop. That is quite the understatement. It is an amazingly different thing when inside of a for loop, and there's some cool stuff you can do there. So let's start with this example and make sure we have our environment variable delayed expansion, which again can be any of these values here. And then for C, so /C is in most commands. Sometimes you'll see people use /K or something like that. But C is pretty common. It just says the rest of the command is command line arguments. However, if you look a little further in the help menu, you'll see this nice thing that for compatibility reasons, /R is the same as /C. That was interesting to me. So hashtag for compatibility reasons, hashtag R is the new C. Let's swap that sucker with R, and it still works. So the way I keep this in mind, because I like to look at like anchor arguments, is I remember CRV. So C and R for arguments, V is for variable expansion. So that's just a fun, Honda did not pay me to put that in there, but it just worked out pretty well. This is also an amazing troll opportunity. All of that white space before the V and the C or the R, you can do stuff like this. This command actually works. The command doesn't play the GIF, but it does work. It actually properly looks at the arguments and then ignores everything else in between there. Also this, what if as an analyst you see this command C echo path? Would you think anything of this? Well, you might if you recognize all that white space leading down to this other command down here. Because /C does not mean anything, it's looking for /C or /R. So when you run this, netstat actually runs. So if as an analyst you're not looking at the size of that horizontal scroll bar, you definitely want to be or enable that line wrap because attackers can use this space for some really devious things. In addition, well, yeah, so we'll keep going with FORcoding. So what we're going to do for FORcoding is take our netstat command and then take all the unique variables and set them in a variable called, or take the unique characters and set that in a variable called unique. And then we're going to iterate through a for loop and put the indexes of each character. So 0 for N, 1 for E, etc. And we're going to build out our netstat command by indexes, and then we're going to end with something that's kind of our delimiter of saying we're done. Then for each iteration of the for loop, we're going to take that index and say, let me take the substring of the unique variable and take that character out and append it to this new one called final. And so in memory, we iterate each iteration, or for each iteration, we basically append the character. And then at the end, we say, hey, if you're the delimiter, then just stop and then call the final result, which we see right here. And so when we run that, we'll see a standard output, all the different lines, and then it finally runs the result for us. To make it harder, we can also add garbage characters inside and then update the indexes. And then, as with everything in Invoke DOSfuscation, you can also optionally add all the other building blocks, a randomized case, removal of white space, addition of white space, commas and semicolons, carets, parentheses, explicit signing, and that will still produce the same result for you. This is also a good troll opportunity in the tool. If you're using not the interactive function, but actually the underlying functions themselves, you can actually, as an attacker or a friendly neighborhood red teamer, put in a troll message to start your unique variable, and it will basically check all those characters and say the input malicious command you want to run. If there are any characters in your input command that aren't in your troll message, then we'll append those at the end, and then it'll get you going. So you can actually set your payload to be a nice fun message there. So there's no reason you can't make our defender's day a little bit nicer and insert a joke or something like that. Reversal is the third option. It's very similar to FORcoding, except instead of specifying all the index values, we're just introducing the /L argument for the for loop, and then setting the index, the beginning index, and then the negative or positive delimiter to go and iterate through that. And similar to FORcoding, we can add additional characters, updating the start and end, and then keep going with that. This is basically talking about, you can use the equals equals for explicit string comparisons, or if you're talking about integers, then you can use equal less than, and these are all randomly selected from the tool itself, so they should be different every time. I'm going to skip these. This is basically just more substring obfuscation for that final variable there that the tool will choose between. The last one is FINcoding, and this was, again, homage to Fin7 and the cool stuff that started all this research for me. So let's say we take all the T's and replace them with uppercase Z's in our initial command that we're setting in this variable. And then somewhere in the command, we're then going to swap and use the Fin7 replacement and say, let me, in memory, replace all the uppercase Z's back to T's. And then call that final sub1 variable. And then let's go back and replace A's with 7s, and then later replace 7s back to A's, and do that one more time. And then when we call it, it actually continues to run. Now this is the FINcoding command in the DOSfuscation tool. This is what the output would have to look like in the original POC. In the POC, it's a lot uglier because I didn't know about the variable expansion with a /v, so I had to make a separate command for every one of these. So there's a ton of ands. There's like the child process tree is like super, super deep and super noisy. In addition, to escape each of the ands for each subsequent command, it took a lot of carets. And as you can see by the end, we're 3 levels deep. We're having to put in 8 carets, or no, 7 carets for the 3rd level of escaping. So it was really ugly. Multiple command invocations, and yeah, all that layered escaping was like really, really ugly. So it's a lot cleaner in the new payload, just because of that V for the variable expansion. So now, quick demo. Please don't use this for evil. And if you're FIN78 or APT32 and define evil differently, please don't use it at all. I know you still do, but I'm going to say that. So in the demo, it starts with ASCII art, as with all of the things that I like to play with, a little bit of colored ASCII art there. But basically, there's 3 components to the tool, and 2 of them are pretty basic, and the 3rd one is where the main meat is. But as with the other obfuscation frameworks, anything in yellow will take you to new menus, so you have tutorials, help menus, all that stuff. So if we go to tutorial, you'll see how we can set a command. We can set our final binary to be explicitly command or PowerShell if we want to introduce that additional escaping. But we'll go to the first one, which is binary. This will simply produce output that you can paste into command.exe that will produce the string CMD or PowerShell. And for all of the options, you'll have like levels 1, 2, and 3 to make it easier to just produce that output. And we can paste it in and see, yeah, that resolves the PowerShell and executes PowerShell. But this is kind of for finding and replacing the references to command and PowerShell and other payloads you might have. For encoding, this will allow us to set a bigger command and actually use the same encoding. So we're just going to do ping 8888. And then we can make sure that's configured properly, and then use environment variable substringing there. And we can also go to level 3, and it'll be a bit more white space, etc. This is also using environment variables not from your system, but from like basically built into the code, so you don't have to worry about if you've mucked around with your variables on your system. Payload is the main thing though, so if we set a nice command here, let's just do a simple PowerShell command to demonstrate the PowerShell escaping inside of the DOS obfuscation escaping. Then we'll make sure that our command is set and the final binary is set to PowerShell. And let's do concatenation. And we'll go with option 1. And then we'll concatenate. So option 1 will basically do the full obfuscation, but not introduce all the carets and commas and semicolons and all that stuff, because you may not want to actually introduce those characters if defenders are specifically looking for them. But we can go full-blown option 3 and get something like that. Clip it to our clipboard, paste it in, and as you can see, it handles the DOS obfuscation and then underside the PowerShell obfuscation as well. And so we'll do another example of FORcoding, which is going to be the for loop encoding, and run that through there. And we can see the same thing, clip it, run it, it still works. And now for me, when I was setting up my test harness to make sure the tool worked, the holy grail was adding all my obfuscation together. So what I did is, in this example, I created a PowerShell payload, hosted it on Bitly, ran that through my invoke cradlecrafter tool to get that level of obfuscation, ran that result through invoke obfuscation to get token linear obfuscation, then I put that in invoke DOSfuscation, did FORcoding, got this DOSfuscation, pasted it in, and this takes like a good 20 seconds because my VM was hating my guts right now. But basically all of this is, it's all inside the for loop for FORcoding, and it's character by character reassembling the 3-level deep PowerShell obfuscated command. You'll see this in standard output, but this never hits the command line. And then when it's finally done putting all of the variables together, it'll finally hit that end delimiter and say, all right, I'm done. Now I'm going to call you, pipe you into PowerShell dash, and it's almost done. Yeah. And run. So how about detecting this crap? All right, and again, there's a lot more detail in the white paper for detecting, including a lot of code snippets and stuff like that. But at a high level, you can look for really long command line arguments for command.exe. You can look for high frequency of these characters. I will warn you, there is a ton of legitimate software out there that does some really crazy, noisy things with all these characters. So for us, when we write these detections, they have to work across like 10 million endpoints or more. And so in your environment, I pray that you don't have any of these solutions that cause me a lot of heartache. But again, your mileage may vary depending on what's in your environment. Also, I look for the obfuscation of very specific internal commands like call and set and for that are required for almost all of the DOSfuscation techniques. So I think it's a lot simpler than PowerShell obfuscation just because it's a smaller subset, but you don't have any of the awesome PowerShell logging for command.exe. Also look for the /r or /v. You will see /v a bit for certain solutions, for certain enterprise solutions. I look for variable substring replacements. Typically, this will be more valuable in like a 7045 service installation event logs or in like registry or other static sources as opposed to dynamic. Suspicious subcommand, this is the part that was several slides back highlighted in blue where I said it's an artifact of the operating system for like subcommands and piping stuff into standard input. I, again, specifically have detections written around looking for the syntax and looking for small substrings. So if you run a lot of these DOSfuscated commands, you'll start to see certain things like with the assoc and ftype and set substrings, they'll actually show up in, since they're running in the for loops as a subcommand, you'll see a separate command.exe process that runs with these. And also an interesting fact is that even if you rename the command.exe binary to foo.exe and then run these subcommands, the subcommand will actually still run as command.exe instead of foo. So it's definitely not just looking at the name of the binary that's running it. So that can also lead to some interesting binary rename detections. I suffer from FOMO, although for me it's the fear of missing obfuscation. So I really go through a lot of extra links to find obfuscation that's out there that maybe I haven't seen before. And to do that, this is one of the things I had the most fun with in this project was to actually release the test harness that I use to develop every detection that we run for DOSfuscation. And I've done this with all the obfuscation frameworks, but my code was always so ugly that I never ever wanted anyone to see it. So I actually spent a lot of time on making this code releasable. And so basically what you can do is you can say, okay, DOSfuscation, let me do a test harness and produce 1,000 iterations of all these different obfuscation options. And when you're using the menu-driven tool, you know he only had the profiles 1, 2, and 3. For every underlying function, there's like over 20 different switches you can toggle and percentages and all that stuff. So as a defender, I wanted them to get more value out of the tool than red teamers and script kiddies. So when you use the test harness, it will not use those profiles. It'll go through and randomly flip all the switches for every single execution. So when you run the test harness, you will get surprisingly more interesting obfuscation than you will out of the interactive tool. And if you don't want to run my code, then I have outputs in text files as well as 4688 and sysmon EID1 event logs. So you can just take that immediately and start to run your testing against all those and see what detections work for you. And so basically in the test harness, you can start to drop in rules. And these are some of the basic rules that just I included in the tool itself on GitHub. And so you can say, okay, I want to look for an unobfuscated for loop, and there's the regex I want to use to look for that. Or I want to look for multiple var substrings, and there's how the regex looks for that. And so what you can then do is then run this across all the payloads, and at the end it'll say, hey, out of these 1,000 payloads, here are 14 payloads that had 0 detections. So let me focus on those and see why there were 0 detections and what I can do to fix that. And so as I was doing the research, the day I found like that fact I could use commas and semicolons, once I put that into the code and got it working, like my detection success dropped like 10%. And so I had to go back to all those failures and say, okay, how do I need to modify these regexes and take that into account? So final thoughts, key takeaways, attackers still using interesting obfuscation techniques. Some of them are being very tasteful and creative and what little things they're obfuscating as opposed to obfuscating all the things. The second one is command.exe is still surprisingly awesome at a lot of these little lesser known, hopefully now more known techniques for like substrings and replacements and stuff like that. And we as defenders, I know it's way easier to say this than actually do this, but like there are opportunities for us to be as creative as attackers when it comes to writing detections. And it's really interesting to go through and start to focus on specific obfuscation techniques to find payloads that we may not have even discovered otherwise, other than the fact that they were using this obfuscation. So in a way, we're actually shaping attacker activity into this funnel. That's not the easiest thing to detect at first, but it actually is far more predictable than anything else they're running, and you don't really have to worry about intent. It's like, oh, I want to know what this command is about because someone didn't want me to know what this is about. So I just want to give a huge thanks to the FireEye Advanced Practices team that I get to work with and all the awesome Maniac consultants that we get to actually see running these detections and finding cool evil in the wild. And a huge thanks to my wife Paige for putting up with all the research that went into this. It was about 1,000 hours when it was all said and done, and far more coffee than hot V8, surprisingly, that fueled this research. And again, I just want to thank you for your time. Here's all the contact information with the source code, the white paper, and before I walk off the stage, I just want to say a huge thank you, and I'd love to say hello and meet you. And if you have any questions, criticisms, anything like that, as long as you don't have a hot V8, then I would love to talk to you. So thank you. appreciate it.
Thank you so much.
Oh, thanks, man.
Good to see you again.
Oh.
A couple years.
Yeah, man. How you doing?
Hanging in there. How about yourself?
Yeah, doing pretty good. It has been. Did we run each other last year or no?
Last year I missed DerbyCon, so I missed your co-brands with Eric. I saw it online.
Oh, gotcha. Yeah, yeah. How are things going?
Oh,